Welcome to Chapter 37 on Import, Export, and Direct Edit. The imported files that we have, you can get to through File, Open, and then you can select the various file types from here. The notable ones that you really need to know about for import are going to be DXF, TWG for basically 2D import. Parasolid's going to be the one that you should rely on the most. Step is probably the next most important one. IGES is a very old standard and it has a lot of different interpretations, so you may or may not get good results through IGES. VDA is a German automotive standard, as I understand it. ASIS can be fairly reliable, but then you've also got a lot of mesh types like VRML, STL, OBJ. There's a new 3D manufacturing format. You'll get some CATIA graphics files, which are not good for geometry, but you can get 3D graphics, Pro-E parts, Inventor parts, Solid Edge, CAD Key, Rhino, and the IDF is going to be for structural, architectural, and facilities type of imports. Unigraphics and Solid Edge should be able to give you Parasolid data, which will be very reliable. The mesh data is currently mostly usable as graphics, but Solidworks also has an add-on package that allows you to use mesh data to create NURBS surfaces. It's not automatic, it's not necessarily pretty or easy, but that's a tool that you might want to use. Once you get data in, and it's very easy to get bad data in, you get an imported feature in the tree. You can right-click on this and go to the Import Diagnostics, and this will give you a rundown of how many faulty faces or how big the gaps are between various faces or edges. And then SolidWorks can automatically heal some of this. Fortunately, this part was made in SolidWorks, so I exported it as a Parasolid and brought it back in, and it came in perfectly clean. That's what you usually expect from Parasolid data. In the case, however, where we get a not so clean import, let's take a look at one of these. Okay, this is a great example of a bad import. SolidWorks is just unable to complete this as a solid. Now you could manually go back through this and try to figure out what's going on, but I can tell you that it's probably more work than it's worth. You can right-click on here, go to your Import Diagnostics, and try to figure out what's wrong. See if you can get SolidWorks to automatically heal some of this, but you can see that there's an awful lot wrong with this model. And at this point, you're probably better off asking the person who originally gave you the data to give you better data. If this is the kind of thing that you downloaded from the internet, well, you got what you paid for. Another thing that you need to look at here is you can see that in some places there are blue edges where you'd think there should be black edges. These edges indicate that they are open edges of surfaces. So these are surfaces that are in some way not merged to the surfaces around them, or there's a gap in between a couple of edges, or there might be a number of problems with these blue edges. Sometimes you can manually go through, and if you're good with surface modeling, you could fix a model like this. But with so many things wrong, you'd probably spend the better part of 2 or 3 days trying to fix it, and then there's no guarantee that your fixes would be correct. So this is kind of the extreme of models that can go wrong. You can also bring in assemblies that can have parts that are bad, so that brings another level of complexity to the import issue. Let's just see if we have a Parasolid in here. Okay, let's open this one. And I want to show this with edges. For some reason, the imported ones always come in with just shaded display, and I really like to show shaded with edges. that helps me get a sense for edges that are tangent and edges that aren't tangent. The tangent edges are going to show up as phantom, not tangent edges are going to show up as solid, like this one. There are some edges, like this one, that will show up a combination of those, and this is a problem with the model. It's not a real serious problem. You know, it depends on what you're going to use this data for. Is this a looks like model, or is it something else? We could go through and do the import diagnostics on this, and we see that it thinks everything's okay, even though I can tell, you know, that is not okay. Now, Solidworks has what it calls direct edit tools. And direct edit is a method of editing a model without having a list of features on the side. It's the kind of modeling that Solid Edge synchronous technology does, and various other modelers are dedicated direct edit modelers. Solidworks is not a direct edit. The opposite of direct edit is history-based modeling. Some people say it's parametric, but I know direct editors can be parametric as well. It's the history-based and the parent-child relationships that are created within the history-based way of working that cause something to be not direct edit. But I'll show you the type of things that SolidWorks calls direct editing, and then I'll show you why it's not really true. In a direct editor, you should be able to grab this face and just drag it or move it or tilt it or something. So you can do that in SolidWorks. Let's use the move face command, and this looks a lot like direct edit. Okay, so I can make a change to this by using a graphic interface, and you know, I can go back. I hit the enter key just to repeat the last command. You can go back in here and say you want to move this a particular amount. Now, if you want to move the whole thing in X or Z, then you have to select all of the faces, or at least all of the outside faces, probably not the top face. You could also, I might clear this selection, I could come in here and select makes it rather difficult, really. So we'd have to clear this out. Sure, there's a way you could do this with a lasso selection, and there. Now we can move this, but moving the hole up and down really doesn't make any sense. But what we can do is we could move that hexagonal hole, which may be a hexagon just as an artifact of import-export, but we can move it in the ZX plane. And if it runs into the side, we're going to have a hole in the side of this boss. So that's the kind of thing that direct edit does. But direct edit would do it without creating history-based features in a tree. A real direct edit program wouldn't leave a trail like this. And also, these things become part of your parent-child history, which is a big no-no. I mean, that's the whole reason for having direct edit in the first place, is to avoid the effects of rebuild history, parent-child relationships. SolidWorks is able to do these things, and they call them direct editing, but it's not really. It's like calling a Pinto a race car just because you painted a red stripe on it or something. So you could also do something like take this face and use the move face and then tilt the face. You know, you could do something like this. That's a direct edit type of thing to do, where to do all of that in a single feature, or to edit a feature to do that, would be difficult or impossible. Plus, notice we're working on an imported part here. That's one of the big advantages of direct edit software. So I don't want to become too much of a commercial for direct edit, but this is what it does, and this is how it works in SolidWorks. Thanks for watching, and best of luck with Chapter 37.